What we're going to look at today is performing some data analysis. And in particular, we're going to talk about the center of the data and the shape of the data. And both of these things allow us to make certain comments on the data, allows us to talk about it a bit further. So let's have a look at center first of all. There's three ways to measure central tendency, okay? And the most common method, the one that you're used to probably using, is the mean, okay? And that's, really commonly used average number of scores in a netball game. So if I, was a shooter in netball and I got 5 in one game, 8 in another, 7 in another, and 12 in another, my average over the 4-game set would be 5 plus 8 plus 7 plus 12, all over the number of numbers which I have, which in this case is 4. Okay, so the equation here, x bar, is what we call the mean in statistics. Okay, so we refer to that as x with a bar on the top, so we call it x bar. Is the sum of all of the x values, that's what this symbol means here, the sum of all of the x values over the number of values that we're summing. Now, mean is good to use when the data is roughly symmetrical, so that means that data is spread around the middle value roughly evenly, okay? And one to think about maybe is if I got the average height of 10D, what I'd predict would happen would be we'd get a bunch of people sort of roughly in the middle with some outliers, some very tall people and some very short people. But the most common thing would happen would be the heights in the middle would be the most frequently occurring. And so the mean is very safe to use when we've got this approximately symmetrical data with no what we call outliers or unusual values. All right, the next method we're going to look at is the median. Okay, and that is the middle value. So what we do basically is place the values in order, smallest to largest, in ascending order. And to get the median position, what we do is we use the number of values that we've got, we add 1 to it and divide it by 2, and that tells us where to go to find the middle value. Okay, it doesn't tell us the middle value, it goes, here you go search and find this spot. Now, median is good with data that's heavily skewed or data with outliers, that has outliers. And I'll comment on why that is later on. The mode is the most frequently occurring value. So we basically look at a data set, and if it's got a most frequently occurring value, we just say that that's the mode. Okay, data sets can be multimodal, okay, but the number of modes is going to be either no mode, so 0 modes, 1 mode, or 2 modes. 2 modes is called bimodal. Okay, when we get more than 2 modes, what we say is actually that there's no mode or no most frequently occurring number. All right, calculate the mean, median, and mode for the following set of data. So the mean, let's do that first. So what we're going to do is add these numbers together and divide by the number of numbers. So to get the mean, we're going to go 10 plus 8 plus 2 plus 3 plus 4 plus 2 plus 1 plus 3 plus 7 plus 8 plus 8, all over the number of numbers. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all divided by 11. And there's no way I'm going to work that one out by hand, so let's plug that into the calc. And divide it by 11. 56 on 11 is our mode. And that would approximate to roughly 5.09. Dot, 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 because it didn't say how many decimal places. And make sure you go back and have a bit of a look at the data set and go, does that seem appropriate? Yeah, if I saw that, I would guess that roughly the mean would be 5. Okay, to get the median, what we're going to do is put this data set in order. Okay, So let's rewrite the numbers. So I'm just going to put a little arrow so that this is my working out for the median. And I hate putting numbers in order smallest to largest. So the way I'm going to do it is go to Menu, Statistics, dump the contents, so clear all on that, and then type in my data set. So 10, 8, 2, 3, 4, 2, 1, 3, 7, 8, and 8. And I'm just going to go Edit and Sort Ascending. Now remember, it asks how many times you want me to do this or for how many lists and where is your list. So if you typed it into list 2 or list 3, you'll need to change that. If you typed it into list 1, all good. All right, so the numbers are 1, 2, 2, 3, 3, 4, 7, 8, 8, 8, 10. All right, so what we're going to do is use this formula here to get the median position. So it's n plus 1 on 2. Now there's 11 numbers. So 11 plus 1 on 2 is equal to 12 on 2, which is equal to 6. And what that means is they want us to go to the 6th number in the data set, and that's where our median is. 1, 2, 3, 4, 5, 6. There it is. So median is 4. That's what our middle value is. All right, now our mode. Our mode is our most frequently occurring number. So we can just look through the sorted data here. We've got 2 instances, and 3 instances of 8. So our mode is 8, which happened 3 times. I mean, that's more information. We just need to say the mode is 8, but it's happened 3 times. All right, so sometimes we need to work out whether it's best to use the median or the mean. And here's one example here of a situation. So if a company was saying on average, we pay out $80,000 to each employee, that sounds pretty good. That sounds really good. But actually, whose salaries are factored in there? And if the salary of the CEO of the company, who's on $500,000 a year, is factored into the average, and all of the other plebs or punters all get $30,000 a year, then it slightly skews the measure of the average. Okay, that the average here, I wouldn't be saying I pay out on average 80,000 because it's just not true. So what I'd be using here in this case is the median, which is obviously going to be 30,000, okay, the median salary, okay? So when we're looking for which one's the best to use, don't choose the one that you think is like the easiest to calculate. It's the one that's most representative based on the data that you've got, or most true for the data. So in this case here, the best one to use is the median rather than the mean, okay? And generally speaking, if the data has outliers, in which case it does here with the CEO salary, we use the median, not the mean. So to do it on the calculator, we've already got this data typed in, but I'm going to type in the new data that is on the screen there. So I'm going to pause the video now and whack it in and then unpause it in a sec. Okay, so the data's in, and now what we're going to do is get the measures of centre using the summary statistics. So list 1 is where we have put our data. So I'm going to go calc and get what's called the one variable statistics. All right, so what it says basically is it goes, hey, where is this data that you want me to summarise? Okay, so the default is list 1. If you typed in your data somewhere else, make sure you drop that list down and indicate where you put it. But I always usually clear out old data and put it into list 1. FREC stands for frequency, and what they're saying is, did you put the data into a frequency table? In which case, where did you put the frequencies? Was it in list 2, list 3, etc., etc.? Well, our data wasn't in a frequency table, so we leave that as the default one, which is basically saying it's not in a frequency table. You hit OK, and it gives you the summary statistics. All right, so these look a little bit different to what's on the screen there. Just pausing it for a sec. Yeah, I've just checked that I typed in the data correctly, and it is. So we're just going to kind of ignore that or use that as a template for what we're going to get. I'm going to go back to the one variable statistics again, And note that X bar in this case is our mean. Okay, so that's our mean is 26.76 dot 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 dot. Just check the number of decimal places required. All right, so over here we're going to say X bar equals 26.76 dot dot dot. Okay, our median. Okay, well what we're looking for in that one is med. Okay, so med is this one here. Our med or median in this case is 25. Right, and our mode, well that's our most frequently occurring number. Okay, so what we've got here is mode, mode, mode. And it says here that we've got a mode of 21, a mode of 24, and a mode of 31. Mode n means the number of modes that we've got, which in this case here is 3 modes. The mode frequency is how many times this happened for each of the modes. So 31 happened twice, 24 happened twice, and 21 happened twice. So what we're going to note here, girls, is this is wrong. Our mode, in this case, we're going to actually say no mode. Okay, because we've got the number of modes in this case is 3, okay? And really, after we've reported on 2 modes, i.e. the data is bimodal, we get 3 modes or 4 modes or 5 modes. It starts to get a bit silly talking about things that happen most frequently. And so we actually say after 2 modes that there is no mode in the data, okay? So just note that those codes there, mode F and mode N, to say how frequently the modes happened, or the number of modes and how frequently they occurred. So for the data set above, there are modes, and it's 21, 24, and 31. The frequency of each of these was 2 in the case of our data set. Now, before we hit the exercises, I want to give you one more example of some data. So let's say we've got a set like as follows. We've got data that is, say, 2, 3, 3, 1. I don't know, I'm asking people in class how many children has your family got? 1, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And let's leave it at that. So that's our data that we collected on number of kids in the family where we've got 8 families interviewed. All right, well, how would we find the summary statistics? All right, let's get the mode first of all, because my feeling is that's the easiest one. So 3, 3, and 3. So our mode is 3. Our mean, again, fairly easy. What we're going to do is add these together. 5, 8, 9, 10, 13, 17, 22. So we've got 22 over the number of families, which is 8. We're going to leave that as the most exact value that we can, which is 11 on 4. Or if it asks you to round it to a certain number of decimal places or nearest whole number, then you're going to round it. All right, let's look at our median. Okay, so we've got 8 families. So let's get the position that has the middle value. So that's going to be n plus 1 on 2, which is equal to 8 plus 1 on 2, 9 on 2, or 4.5. Now, when this happens, girls, what we do to get the median value is, if we get this half number happening here, this means that the median is a theoretical median or theoretical middle value that happens, and this means that it's between the 4th and the 5th number. Now we go to our original data and let's put it in order now. 1, 1, 2, 1, 2, 3, 3, 3, 4, 5. I think I got them all. 1, 2, 4, 6, 8. All right, so what I do is I go find the 4th and the 5th piece of data. 1, 2, 3, 4. Here's the 4th and here's the 5th. So it's the middle value. That's what we're looking for. And the way to work out the middle value between 2 numbers is we average or get the mean of those 2 numbers. So what we're going to do is say that the median is 3 plus 3 all over 2, which is 6 over 2, which is equal to 3. And that's easy to pick that one. Okay, But where it can help to understand that the median between two values is using the mean formula is just say your middle value, one of them was 2.0136 and the other value was 7.812. So they're our two numbers. What we would do then is add those together and divide those by 2 to get the theoretical median. Because really, if I asked you what was in between these two numbers here, between you and me, I've got no idea, and I probably hope that you wouldn't either. So that's the approach when we get this situation happening for median, which is we get 4.5 or 5.5 as an answer to that particular question.